I'm going to discuss about the electrochemistry part in A-level chemistry. So as a initiate, I'm going to conduct this small video in English medium. So this is very helpful for English medium chemistry students in all around Sri Lanka. So first of all, I would like to start this lesson from this part because you should be able to understand so what about the part of the electrochemical cell. So electrochemical cell actually based on two electrodes. So before going to that, we have to get some very little bit idea about the electrodes. So as a part of that, I'm going to introduce about the metal and electrode. So metal and electrode means when consider about now for example, let's consider about magnesium metal rod. So magnesium metal rod just placed in a magnesium ion solution. So I'm going to show in this board. So now, in this diagram, you can see a magnesium metal rod just placed in a magnesium ion solution. So, here, when consider about this solution and the metal ion and the metal rod, so magnesium, this in the magnesium metal rod, some magnesium metal may be can be able to oxidize. That means just remove electrons from this metal and just remove electrons from this metal and just go into this solution side. So this phenomena we call magnesium just removing electron and convert into magnesium 2 plus ion. This magnesium go into this solution, magnesium 2 plus ion. This phenomena we called oxidation of magnesium. So when consider about this mixture and this diagram, when consider about this magnesium 2 plus ion just removing electron here and some electrons, they have some electrons around this area due to the oxidation process of magnesium metal. But and then this magnesium 2 plus ion in the solution, so they have another ability, so they can take this electron or they can gain this electron and just convert it to magnesium. That means this process we called oxidation and the reduction. So magnesium ion and magnesium metal just convert into magnesium 2 plus. Magnesium 2 plus means this is called oxidation process. Okay. Now, when consider about the magnesium 2 plus ion in the solution, so it can gain some electron and then convert into magnesium solid. So this is called reduction process. So at the same time, they may have some oxidation process and reduction process. So after some times, the rate of reduction and rate of oxidation will equal to each other, the rate of oxidation and reduction. So when they exist this type of forward reaction rate and the backward reaction rate. So you can see like this reaction, magnesium solid, just backward and forward reaction, convert into magnesium 2 plus or magnesium 2 plus converted to magnesium. So they exist at equilibrium. So equilibrium means oxidation reduction equilibrium. So when consider forward reaction is the oxidation process and backward reaction is the reduction process. So oxidation and the reduction process and the rate of these reactions are equal to each other. At this point we call there exists a dynamic equilibrium in between magnesium metal and the magnesium solution. So in this electrode you can see the oxidation reaction and the reduction reaction equal to each other, and also if there is if there is a possibility to remove and moving of electron from this metal to solution side of magnesium 2 plus ion, so they should have some electrode potential, so there should have voltage difference to move the electron. So when consider about this electrode voltage potential or voltage difference, so it should be able to move electrons, and they should have some voltage difference. So meaning of that, this metal ion and the solution can act as a electrode potential. So this type of system we called electrode potential as the uh, occurring electrochemical equilibrium here. Okay, so when considered same mass, so instead of magnesium and magnesium 2 plus ion, uh, if we place a copper rod in a copper 2 plus solution, then they also may have some same kind of equilibrium for the copper ion and copper metal and the copper ion. So this type of electrochemical cell, same type of reaction occur like this: copper solid just convert into +2 electrons. So here also, so same as copper also act as a this type of system. So when consider about this system, we call magnesium ion electrode, and this system we call copper ion electrode. Okay. Now we are going to discuss about what about the equilibrium in that system. So when consider about the when consider about the equilibrium, so in that equilibrium system, the oxidation process of magnesium just start from the high rate and just become reducing and the level off. So this is the oxidation process, and this is the reduction process. So after some time, the oxidation and reduction rates are equal to each other. After this point, there exists a dynamic equilibrium. So electrochemical and electrochemistry of the A-level chemistry, so based on this equilibrium, so you have to get this idea. Okay, let's think about magnesium ion electrode. So in this magnesium ion electrode, so previously I said there exists some electrode potential in this magnesium ion electrode, but so we can't measure the absolute electrode potential of this metal ion electrode. So reason is the oxidation reduction reaction and happen at this the oxidation and the reduction reaction simultaneous occurring at this solution. So if you place a voltmeter to measure the electrode potential or voltage difference of this solution and this system, this diagram, it is very difficult. So it may have again continuing this type of equilibrium in this system. So it is very difficult. So for that we have to go for the alternative method, or we have to go for the measurement of voltage with respect to another electrode. So for that we have to go for a standard electrode. So a standard electrode means we have to discuss about what is the electrode or what is the standard electrode. So far we have discussed about standard, not we have, so far we have discussed about the metal ion electrode. Then we are going to move into the standard metal ion electrode. Okay, to measure the voltage difference of a metal ion electrode, we have to use a standard electrode. A standard electrode means generally we use as the standard electrode we call the standard hydrogen electrode. Standard hydrogen electrode means, so I'm going to draw the diagram of a standard hydrogen electrode. Here we use this type of system. So this is called a standard hydrogen electrode. In this standard hydrogen electrode, we use 1 mole per cubic decimeter H plus solution, just the platinum wire, and we have to place a H2 or hydrogen gas inside this solution, and as the covered system, so you have to give hydrogen into the system. So when consider about this H2 and H plus and this system, there exists same type of as previous one, oxidation and reduction equilibrium. So this is called the standard hydrogen electrode. Here the pressure of the hydrogen should be 1 atm and the temperature of the solution should be 25. So those are the standard condition. So when consider about this system, this equilibrium takes place in this system. Hydrogen gas, convert into H plus, and oxidation and reduction reaction, simultaneous reaction just happen at the same time. So when consider about this standard hydrogen electrode, as a reference we just used the electrode potential of standard hydrogen electrodes as 0 volt. So therefore we are going to use this standard hydrogen electrode to measure the electrode potential of other electrode. Now when we combine this standard hydrogen electrode with any other type of electrode, we call that is related to a standard. So example, now I am going to connect this standard hydrogen electrode with magnesium metal ion electrode. Okay. And here we just connect magnesium metal ion electrode. This took this connection, and we just connect voltmeter to measure the voltage. And here we have used salt bridge for the connection in between the solution. The purpose of the salt bridge is the ion exchange process. So here now you can measure the voltage of this magnesium ion electrode with respect to the standard hydrogen electrode. So when we connect this standard hydrogen electrode to this magnesium ion electrode, then it's called standard magnesium ion electrode. So when as same as you can use a standard copper ion electrode, when we use as previous one a standard copper ion electrode, when you connect the standard hydrogen electrode, it is going to the standard term. So same type of electrode you can use. So electrode potential of this type of metal ion electrode, just there is a measurement with respect to this one. So only thing you have to understand when consider about the standard hydrogen electrode connection, there is a formation of a standard electrode, whether it is magnesium ion, copper ion, or any type of metal ion. So now we are going to discuss about how we can prepare the gas electrode. So hydrogen, the standard hydrogen electrode also gas electrode, because we use gas and gas. So same type, if we use similarly we can use we can use Cl minus solution and Cl2 gas to prepare the chlorine gas electrode. So when there is a connection between chlorine gas electrode and the standard hydrogen electrode, then we can obtain the standard chlorine electrode. That's how we can prepare a standard electrode. So in electrochemical cell, we just prepare a standard gas electrode and a standard metal ion electrode. So after the measurement of this type of voltage difference, there's a prepared the electrochemical series according to the standard hydrogen electrode. So standard hydrogen electrode used as the reference value, and then other electrode just measured. And the next slide you can see the standard electrochemical series, and in this electrochemical series there's a when we go to top to bottom, the reduction ability of the elements just increase. When you go to bottom to top, this oxidation ability increase. So you can see now the electrochemical series. So using this electrochemical series you can find, so when there's a connection of two electrode, which one is the oxidation end and which one is the reducing end. So use this electrochemical series for further studies of this electrochemical series. Okay. So when consider about electrochemical cell, actually electrochemical cell is the connection between two electrodes, just simply connection between two electrodes. Now just consider about as example I'm going to use zinc ion electrode and copper ion electrode. Now here you just connect voltmeter to this system, and then according to electrochemical series, just we see the what about the electrode potential or standard potential of copper and zinc. The copper standard electrode potential for zinc, it is minus 0.76, and for copper it is plus 0.34. So these are the electrode potentials. So these electrode potentials are measured with respect to the standard hydrogen electrodes. This is the standard electrode potential for copper, and this is the standard electrode potential for zinc. So normally it is given like this in some questions. Copper like this. In some question it will be given like this, and some question for zinc it will be given like this. So then you have to identify which one is the oxidation part and reduction part. So that part you have to decide according to the electrochemical series. So when consider about this copper and zinc in electrochemical series, just copper minus sign, and here this one positive sign. So when consider about these two electrode, you have to find anode and cathode or oxidation and reduction part. So I'll show you a very useful method to keep it in mind to find the oxidation part and reduction part, to find the cathode and anode in the next one. Now you have to use the electrochemical series for this purpose. Now think about if both electrode values are positive. Now for examples, both are positive, means first one, both values are positive. For examples, now think about this one. These both values are positive values. Then you have to decide which one is the anode or cathode, or which one is the oxidation part and reduction part. So according to electrochemical series, when you consider about top to bottom, in the top area there's a negative electrode potential. When you go down, there's a positive electron. So when you go down the group or down the series, just reduction ability increase. That means which one has the highest positive nature, it is going to the reduction part. Positive nature, that means higher positive nature going to the reduction part. At every time try to keep it in mind the high positive part. If both are positive values, the high positive end is the reduction part. Keep it in mind. The other part is oxidation part. When consider about second one, if both values are negative, example, if both values are negative, then when consider about the electrochemical series, the less negative one, this is the reduction potential. Okay, if both values are negative. Then third part, the values has this opposite sign. We consider about opposite signs. So one end has 0.25 plus value and another one end has 0.12 negative sign. So when consider this one, so reduction part is the most positive part. So this one is the reduction part. So according to this one, you have to decide how we can identify oxidation part and the reduction part of an electrochemical cell. If both values are positive, both values are negative, or if they have opposite sign, now you can identify which one is the oxidation part or reduction part. Now according to this one, now we are going to identify which one, or how we can identify the oxidation part and the reduction part of previous example, zinc and copper. So in previous one, the electrode potential related to copper is plus, and related to zinc it is minus 0.76. So according to this value, now you can identify which one is the oxidation part and the reduction part. So reduction part is the most positive one. So this is the reduction part. So this is the oxidation part. Now you can identify oxidation part and reduction part with respect to this simple electrochemical cell. So simple electrochemical cell, this type, just given values, you can, the only thing you have to identify reduction and oxidation part. So at the end of this video, I'll give you some examples to practice this one, to find the oxidation part and the reduction part. Okay, so now you can write the oxidation reaction and reduction reaction according to this one. So just reduction part is the copper, the solution in this solution, and copper 2 plus just convert into copper solid by gaining electrons. So this is the reduction reaction, just simple, nothing here. Okay, this is the reduction reaction. So eventually then you can find the oxidation reaction, just zinc convert into zinc 2 plus, and this is the oxidation reaction. Then oxidation and reduction reaction just we can write. So then you can write the overall reaction for the electrochemical cell with respect to the relevant to zinc and copper, just previously we discussed. So you can write the reaction So this is the just simple reaction for that example. So zinc convert into zinc 2 plus, copper 2 plus convert into copper with respect to oxidation and the reduction reaction. So this is the overall reaction for this electrochemical cell. Just simple, you have to only identify which one is the oxidation part and the reduction part. So this is very simple one. Only thing you have to check about the values of the voltage difference or electrode potential of relevant electrode. Now in A-level exam you have to identify which one is the oxidation part and the reduction part. Then you have to identify what is the anode and cathode. So this is very important thing in electrochemical cell. Anode and cathode, it is very useful. Okay, in the exam they ask about write the anode reaction and the cathode reaction. So identification test or identification for this part, you have to use very simple method. I am going to give you that simple method. Okay, now according to electrode potential of any type of electrode, you can find now what is the reduction part and the oxidation part. So for the cathode and anode, just try to keep in mind, this is the tip, actually very important tip. Just try to make it mine. REDCAT. REDCAT means, so this is very simple one. REDCAT means the reduction part is the cathode of electrochemical cell. REDCAT. Very simple. You can identify. Now, if they ask about write the anode and cathode, then you can find just find only reduction part, and reduction part is the cathode. Then you can eventually you can find the anode. That is very simple. REDCAT. So when consider about the electrochemical cell, so anode and cathode, they have some charges. positive or negative end. You have to find which one is the positive end and negative end. That one also you can use here, REDCAT, and use this one, REDCAT and CAP. REDCAT means reduction part is the cathode, then cathode is positively charging end. That is simple, just keep in mind. Then other part is the anode, is just simple, anode is negatively charged, anode is the oxidation part, just you can keep it in mind, very simple. Okay, now any type of electrochemical part, you can use this part to solve any type of electrochemical cell. Okay, now I'm going to discuss about next electromotive force of electrochemical cell. Electromotive force means, so what is the amount of energy we can get, just simply. Okay, so when consider about electromotive force, we can there's an equation to find the electromotive force. So you can use this equations, any type of this equation, to find the electromotive force. Okay. So electromotive force means you can use this equation. EMF is the cathode, or electrode potential of cathode minus electrode potential of anode. So when consider about electrochemical cell, they should have some spontaneous reaction. Spontaneous means just they release the energy in this part, electrochemical cell. So if you have get any negative value for EMF value, so that is actually incorrect value. Then you have to change the cathode and anode, get the positive value. Positive, the EMF value should be positive for electrochemical cell. If it is a negative, it is not a cell. So we have to supply energy. So electrochemical cell means we have to gain energy from that cell. So therefore, just try to keep it in mind. So now previous part we discussed about how we find the anode and cathode, then you can apply that same theory for here. So previous one, so in previous examples, the zinc minus 0.76 is the anode, copper minus plus 0.34 is the cathode. So according to that, we can find the electrochemical or electromotive force with respect to zinc and copper. Use this equation simply, you can find what is the EMF related to previous example, zinc and copper. Okay, so here you can use this equation, cathode minus anode is the EMF of the electrochemical cell. Now we just discuss about what is the anode and cathode and what is the oxidation part and reduction part of electrochemical cell. Next we are going to discuss about what is the standard notation for cell reaction or overall reaction. There is a standard notation. So now you can see the guidelines. So for the connection between oxidation part and reduction part, previously we use salt bridge. In sometimes we use called the liquid Johnson also, liquid Johnson. So there's another type of one. So in the guideline you can see, if you use liquid Johnson or salt bridge, what is the sign we should use for this guideline? So when consider previous one, first you have to identify what is the oxidation part and reduction part, then you can write the what about the standard cell notation and standard reaction. So in previous one we use zinc and copper, so we just identify zinc is the oxidation part and copper is the reduction part. So when you write the standard cell notation, first you have to write in one side oxidation part and in other side reduction part. You have to separate this oxidation part and reduction part based on the connection between those two electrodes as liquid Johnson or a salt bridge. If you use salt bridge, so previous one we use salt bridge, just place separation between salt bridge by two vertical lines like this. Then in the right side you have to write the reduction reaction and the left side you have to write the oxidation reaction. And zinc and you have to mention the all physical state, and then you have to separate all other phases. Here solid phase, this is liquid phase, by one vertical line like this. And also you have to mention the concentration of solutions here. Solution. What is the concentration here? Normally we use 1 mole per cubic decimeter, and also mention the temperature also. So oxidation part you have to write like this in this here, and in other side you have to write the reduction part. So in this reaction we use left side oxidation part and the right side reduction part. And reduction part here, copper 2 plus, aqueous medium, 1 mole per cubic decimeter, 35 degrees, and separation for liquid and the power. That is enough. So this is the standard cell notation for previous examples. So according to this one, just only you have to mention this concentration, strict, and then here the separation between electrode as liquid Johnson or a salt bridge. Here we use salt bridge, therefore you would use two vertical lines. So this is the standard cell notation. So according to this standard cell notation, also you can find the EMF value with respect to this one. So there's another equation, EMF. According to this equation, EMF equal E RHS minus LHS. This equation also you can use to find the EM. Nothing special, only thing you know the values of electrode potential, then same as previous one. Only thing, the simple example. So using this one you can identify what about the oxidation part, reduction part, overall reaction, and this one. So at the end of this part I'll give a video, some part about some example. Just try to do these examples, and then in the second video we discuss how we can identify. So what about the exam questions, and what about the other type of electrochemical cell, what about the practical methods likewise. So just interested you try to understand all of these. Then second we discuss about the exam questions and also some other just what are the special type of electrodes and electrochemical cells.